So this is the 53rd video on Newton's laws of motion. This is in continuation of the 52nd video. So in this problem also I'll take a problem involving constraint theory. See, but in the previous questions on constraint theory, I have taken those examples in which there was no variable angle during the course of motion of the system. Because of this, the constraint relation for displacement, velocity, and acceleration had identical format. So just by putting t dot a sum of t dot a equal to 0, we are getting the direct constraint relation for acceleration. But when there are certain angles which are variable during the course of motion of the system, then you cannot use this method. If you use t dot a sum of t dot a equal to 0, then we get a contradiction. We get wrong results. So I'll demonstrate the concept. Okay. See, the question is this. Consider the diagram shown below. Consider this is a fixed, smooth, horizontal rod. Fixed, smooth, horizontal rod. Okay. This is a ring. This is a ring of mass 2m. This ring can slide without friction along this rod. Now this string is attached by means of an inextensible string to another hanging block of mass m. This is a fixed smooth pulley. This is a fixed smooth pulley. Okay. And this is a string. This string is massless and inextensible. Massless and inextensible string. Okay. There is no friction anywhere. Here also there is no friction. Here also there is no friction between string and pulley in contact. Okay. So this is a diagram for time 0. This angle is initially theta naught equal to say 30 degree initial. Okay. And the system is released from rest. System is released from rest. So when the system is released from rest, due to gravity, this block starts moving down and this ring moves rightward. Okay. So at an arbitrary instant t, the situation is as shown below, shown here. This is a fixed smooth horizontal rod. This is the pulley, fixed pulley. Ring has moved certain distance towards right. So this is the block of mass m. This is a fixed pulley. At this instant, the string makes an angle theta. The ring has a horizontal acceleration a with respect to ground, and the block has a downward acceleration b with respect to ground. Suppose at this instant 2m has a speed of say va with respect to ground, and this block has a speed of vb with respect to ground. Also at this instant, acceleration of 2m with respect to ground is aa in rightward direction, and at the same instant, acceleration of this block is in ab in downward direction. Now we have to find the relationship. Why we have to find the value of AB? AB has to be determined. Okay. AB has to be determined from this at arbitrary instant. At arbitrary instant, you have to determine AB and also the initial value of AB when the system is released from rest. Also find the value of AB. Okay. First we have to find AB at arbitrary instant t, and then from that expression we have to find the initial value of AB when the system is just released from rest. Okay. So this is the initial situation at time 0 when the entire system is at rest. And this is the situation at arbitrary time instant when this string, ring and this block all are moving, but this pulley remains fixed. Okay, fine. So now first of all what we'll do, we'll show the tension in the string. The string is massless and there is no friction between string and pulley anywhere. So at all points of the same string, tension is the same. So let the tension in the string at all points be equal to T, say. Alright, fine. Now what I'll do, I'll draw the free body of this block of mass M with respect to ground frame. I'll show in the diagram itself. Okay. And this free body, I'll draw the free body of 2M. N, okay. These are three forces acting on this ring of mass 2M. Normal force upward direction due to the rod, 2mg downward direction, weight of the ring, and tension T which acts on the ring in this direction. Fine, alright. Initial value of theta was given to be 30 degree. Okay, fine. This is M, this is 2M. Alright. So this I'll rub it now. M and 2M, 30 degree. Okay, very good. So what I do first, I write down the Newton's law equation for this block in downward direction with respect to ground. So from this free body, I write the equation in this way. mg minus t is equal to m times b, first equation. Then apply the Newton's second law equation to ring with respect to ground in this direction. In this direction only t cos theta acts. These do not have any component in that direction because they are vertical forces. So we get t cos theta is equals to 2ma, second equation. Okay, fine. mg minus t is equal to mb. T cos theta is equal to 2ma. Now count the number of unknowns. A, B, T, three unknowns are there. So we need three equations. So one equation we have to find from constraint. At certain instant, suppose this gets displaced, this ring gets displaced rightward by amount dx. And this block gets displaced downward by amount dy. Okay. Now here I have to see one thing I would like to say. As time passes by, theta goes on changing. You can see theta is not constant. So here the constant relation for displacement, velocity and acceleration. Constant relation for acceleration will be different from the constant relation of displacement and velocity. Two things I have to say. First of all, in this case also, because even though theta is changing with time, still constant relation for displacement and constant relation for velocity, they are identical in format. But constant relation for velocity and constant relation for acceleration, they are not identical. There will be some variation, additional term will come. So that I'll emphasize, okay. So first I use the basic concept that constant relation for displacement I start. String is inextensible. Length of string is constant. Total work done by string on all bodies in contact with it adds up to 0. So consider this ring. T acts in this way. Its displacement is dx in rightward direction. In time t to t plus dt. What do we write? Work done by string on this 2m. How much will it be? T dx cos theta f dot dr. Now this string also is in contact with the pulley, but pulley is fixed in ground frame. In ground frame, string does 0 work on this pulley. So 0. Okay, fine. Now you have to see this one. On this t acts in upward direction, it gets displaced dy in downward direction with respect to ground. So how much work does that the string do on this block? Minus t dy. Why? T dy cos 180 degree. This adds up to 0. Why 0? Because length of string is constant. So t and t will now cancel out. Dy becomes what? Dx cos theta. This is the constant relation for displacement. Okay. Now this displacement is in what time? T to t plus dt. And this displacement is also in time t to t plus dt. Now I divide both sides of the equation by dt. What do you get? dy by dt barabar is equal to dx by dt into cos theta. But what is dy by dt? It is nothing but Vb. And what is dx by dt? It is nothing but Va. Vb equal to Va into cos theta. Alright, fine. Vb is equal to Va into what? Cos theta. Alright. Now rub this one. So again see, constraint relation for displacement and constraint relation for velocity have the same format. Both have identical formats, you can see. Now we have to write down the constraint equation for acceleration. So now this equation is valid for all instants. So I differentiate this equation with respect to time on both sides. So what do we get? dv by dt equal to d by dt of what? va cos theta. So this becomes what? ab. Okay, fine. And what does this become? This I differentiate using product rule of calculus. So this becomes dva by dt into what? Cos theta plus va plus va into d by dt of what? Cos theta. So this becomes ab. What does dva by dt become? That is nothing but acceleration of the ring aa cos theta plus va. This I use the chain rule. D by d theta into cos theta into d theta by dt. Okay, fine. Now, so we get AB is equal to AA cos theta. This becomes minus sin theta by rule of calculus. And this becomes omega, angular speed of string at time t. So this becomes omega and d by d theta of cos theta becomes minus sin theta. So this becomes minus omega VA into sin theta. Well, omega is nothing but d theta by dt, angular speed of string at time t. So see, this is the constraint relation for acceleration. This is the constraint relation for displacement. This is the constraint relation for acceleration. Now see, constraint relation for displacement and velocity, they have identical format. Just replace dy by vba and dx by va. Okay, and but you see, constraint relation for acceleration is not identical to both of them. See, there is additional this term. So constraint relation for acceleration is totally different from that of displacement and velocity. All right. So now we can solve this. Use this problem to solve the problem. Okay, fine. So this B is nothing but AB and A is nothing but A. They are just the same symbol. Okay. So I just rub this, remove this. Okay, fine. All right. This A is AB. I have just replaced by them. And this AB just equal to nothing but it's just B itself. I hope it is clear. I just simplified the notation. AB replaced by B and A I replaced by A itself. Okay, there's no problem about that. Now we have to solve these questions. Three questions we have to solve. Okay, to get the answer. So from this A and B I substitute in this. So we divide this by M. So B becomes how much? G minus T by M. What about A? I divide this by 2M plus T cos theta by 2M. Okay, A cos theta. A becomes T cos theta by 2M into cos theta, one more there is. Okay, minus omega V sin theta. Alright, now I take T by M on one side. 1 plus 1 by 2 cos square theta. Okay, that becomes G plus omega V sin theta. Alright, fine. Alright. Okay. So I substitute here T by M. I solve this. So T becomes how much? T becomes 2M G plus V omega sin theta by 2 plus cos square theta, this T. I have to find the value of A and B. A and B have to be determined. Okay. So A we get from this equation. T cos theta is equal to 2MA. Alright. So T cos theta is equal to 2MA. Meaning A is equal to 1 by 2M into T cos theta. Now if I divide by 2M, this 2M goes away. And a cos theta comes here. Cos theta into G plus omega v sine theta 2 cos square theta. Alright, fine. So, say I obtained the value of A is equal to A, acceleration of this. Okay, fine. This is the acceleration of ring with respect to ground at arbitrary instant. And what about B? B we get from this. B is equal to A cos theta. A cos theta minus omega v sin theta. So this becomes B is equal to A cos theta. I place A here. So cos square theta into G plus omega v sin theta minus omega v sin theta. As you see, this is the expression for B and this is the expression for A. But we have been also asked to find the value of A and B at initial instant. So at initial instant, omega was 0 because system was released from rest. These are the accelerations at arbitrary instant. This is at some instant t. This also has acceleration at some instant t. At initial instant, system was released from rest. So just after that instant, system was at rest. So omega becomes 0, d theta by dt 0. And v is also 0 initially. At t is equal to 0 plus, system was released from rest at time 0. T equal to 0 plus, system was at rest. That meaning omega is 0 and v is also 0. So this term will go away, this term will also go away. Fine. So how much do if you substitute omega and v0, this term goes away. This term also goes away, this term also goes away. So in that case, A becomes what? G cos theta by 2 and theta becomes theta naught. At initial instant, theta becomes what? Theta naught equal to 30 degree given. G cos theta naught by 2 plus cos square theta naught. Okay. And how much theta naught is? Theta naught is 30 degree. So it becomes G root 3 by 2 upon 2 plus 3 by 4. So this becomes how much? This becomes 2G root 3 by 11. This one answer we have obtained. 2G root 3 by 11. This is the value of A. Alright. And what about B? B also we substitute, remove these two terms because they are 0. And instead of theta, we write theta naught. So B becomes how much? B becomes G cos square theta naught. Cos square theta naught becomes 3 by 4 by 2 plus cos square theta naught 3 by 4. So this becomes 3G by 11. This is required acceleration of the block of mass m at arbitrary instant. So this is the required answer. So in this example, I demonstrated that when there are variable angles in the problem, that is during the course of motion of the system, some angles are changing with time. Then the constraint relation for displacement and velocity are still identical in format, but constraint relation for acceleration has a different format as compared to that of displacement and velocity. So in such cases, to write down the constraint equation, we first have to start from the constraint relation for displacement. Then after dividing that quantity by dt, we get the constraint relation for velocity. And after differentiating that equation with respect to time, we get the constraint relation for acceleration. And that we get the constraint relation for acceleration at arbitrary instant. And then what we have to do, that from that instant, if you are asked to find the accelerations initially, then when the system is just released from rest initially, then omega and v are both 0. So that simplifies to this case. Alright, fine. So this I fully explained. So you go through it properly. In case you have some doubt, you write in the comment box, I'll clarify it. Okay, so this I close it now.